Alright, it's time for a new topic. We're going to introduce waves. Now, this topic is surprisingly broad. There are a lot of different kinds of waves, not just water waves like you see pictured here, but there are a whole bunch of different kinds of waves, and we're going to talk about what is a wave and what are some basic vocab terms for talking about waves. That is this video. By the time we're done, we will have covered a whole lot of info about waves. Not in this video, but in future videos. So this video, basic terms. Alright, so what is a wave? A wave is a disturbance or oscillation that transfers energy through matter or space. So in this case of the picture, there was a water droplet that fell here that causes a disturbance in the water, which makes the water go up and down, and then that radiates outwards, and you can see the crests here. Here's a crest, little trough in there, and there's a crest. We'll talk about those terms in a minute, but you can see the wave pattern there caused by this disturbance of the drop falling in the middle. All right. Oscillation, that just means back and forth motion. So a motion back and forth, boom, 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 kind of like a pendulum. A pendulum swinging would be an oscillation. Okay? Alright, so what are the parts of a wave, you might wonder? Now, some of this is probably review. You've probably talked about these before in other classes in the past, but here we go. This is a typical transverse wave. It looks like a sine wave, basically. And there are these major parts to the wave. Alright, first we have wavelength, and basically that's how long the wave is, amazingly enough. You basically measure wavelength from one part of the wave through one complete cycle and back to the same part of the wave again. Right? So you could measure that from the trough to the trough as it's measured here, or you could measure it from a crest to a crest. That works too. You could measure it in the middle, but that's a little bit dangerous because if you measure in the middle, you could start here, but you do not end here. That's not one complete cycle. So you would have to go here, here, and back to there. That's where it's the same point again as here. Alright, so just keep that in mind. It has to be, this is on the way up here, so you have to go all the way through the wave until it's on the way up again, and that's the next part you would measure if you use the middle to measure the wavelength. Alright. Next we have amplitude, and that is the displacement from the rest position. Alright, this line here would be like if this is a rope we're shaking up and down, then this line would represent the straight rope when it's not being shaken, and then the blue line would be the rope when you're putting waves into it. The amplitude is the distance from the middle. It is not, I repeat, not this whole distance. Not that whole distance. It's only the distance from the middle, the rest position, to the crest, or the rest position to the trough. It is not the entire height of the wave. Alright, I've already used these terms a couple times, but the bottom of the wave is called the trough, and the top of the wave is called the crest. So the wavelength has a number value, and the amplitude has a number value. The trough and the crests are just names for parts of the wave. They do not have numbers. So in addition to those parts of a wave, there are a few other things you need to know about waves. The first one is called frequency, and this is basically the number of complete oscillations that pass a specific point in 1 second. The units are called hertz, or you could also call that 1 over seconds, which is a weird unit, so we call it hertz after one of the first guys to work with waves and quantify them. This is just a little visual to help you picture it. Let's suppose that you are standing right there, just a little stick figure guy, and the wave is coming past you, like so, this way. Here's a little, just, obviously you wouldn't see the wave looking like that unless it's a water wave, but in any case, the wave is coming past you, and the number of complete oscillations, so say from the crest to the crest, that's one complete oscillation, or one wavelength. The number of those that pass you per second is the frequency. So if you've got like this is going at a rate of 1 complete wave each second coming past you, then that would be 1 hertz. Now, sounds and light and all of that typically are way more than 1 hertz, but that's just to give you an idea. If it was 1 wavelength per second, that would be 1 hertz. Okay, so what else do we have? We have velocity, and you guys already know what velocity is. We've talked about that a ton at this point, but basically velocity is just a measure of how fast the disturbance or oscillation or wave or whatever is traveling in a particular direction. So basically it's just numerical value, usually measured in meters per second. That's the standard units. Just like for everything else. Okay? Cool. Alright, so now we've got the question of what are some examples of waves? Well, we've already been talking about some. There's water waves. We can have light. Light is a wave. It's an electromagnetic wave, in fact. Visible light is right there on the EM spectrum. And then you've got sound waves, which travel through the air or water, or I suppose solid walls as well sometimes. And then you've got the whole electromagnetic spectrum, which includes all of these things: radio waves, microwaves, infrared, which we talked about when we were learning about heat and thermal physics, visible light, which you guys are obviously well acquainted with, ultraviolet light, X-rays. When you go to the dentist, they take an X-ray of your teeth, or if you ever had a broken arm, they probably took an X-ray of that. And then gamma rays, which are involved with nuclear decay, as we talked about recently. So there you have it. And then this diagram also has some pictures of things that are approximately the same size as the wavelength of these different parts of the electromagnetic spectrum. The only difference between, say, a radio wave and a gamma ray, honestly, is its frequency and its wavelength. Otherwise, it's exactly the same kind of thing as each other. Totally crazy. Same thing with visible light, same thing with infrared or ultraviolet. They're all basically the same thing. The difference is how much energy they have based on their frequency and their wavelength. Alright, but anyways, that's some examples of what are waves in everyday life. And the last thing I want to cover in this video is this equation, which is one of the main equations for this entire unit. It's called the wave equation. And basically this is it. V equals F times lambda. Velocity equals frequency times wavelength. So that is the relationship among these three quantities that are important for measuring with waves. You've got frequency, you've got wavelength, and you've got velocity. So if you know how fast the wave is traveling, and you know its wavelength, you could calculate the frequency, and so on and so forth. If you know 2 out of these 3, you can calculate the third one. That is cool! Anyways, there we have it. Thanks for watching, and I'll catch you next time.